Good evening, everyone. On behalf of Kalam's Institute of Youth Excellence, ISRO Space Tutor, I extend a warm and enthusiastic welcome to all our learners, dreamers, and future explorers joining us today. I am Deepshika, student coordinator of KIYE, and I'm glad to be your host for the Lecture-10 of Aryabhata Space Utsav, a year-long online lecture series aimed to bring the marvelous of space science right to your screens. This series was started to honor Aryabhatta, India's first satellite, and to spark scientific curiosity among students and educators nationwide. Our theme is Space is the Next Destination. Let's explore it. And today, we continue our journey with a very special session. For those who are very new to us, Kalam's Institute of Youth Excellence is a non-profit organization that carry forward the vision of our beloved Dr. APJ Abdul Kalam sir. Our goal is to inspire and guide young minds, help them grow their skills, and prepare them for the bright future. KIYE is an organization leading by the students for the students. It has been organizing various flagship programs and initiatives to reach every corner of India. This Aryabhatta Swarna Jayanti Space Utsav is one such initiative, organized to commemorate 50 years of India's first satellite, Aryabhatta, and to inspire young minds towards space research and exploration. Where you can interact with our short audio-visual presentation that showcases the vision, achievements, and impact of KIYE. Now the video starts.
नहीं एक जश्न है भारत रग रग में है जीत की आदत ऐसा हुनर दुश्मन भी सलामी दे तू सूरज हम तेरे उजाले तुझसे जुदा नहीं होने वाले आखिर तक हम सफर दिखेंगे के जय हिंद जो नस नस में है हर बाजी फिर बस में है जिद ठान के हिंदुस्तान बोले Kalam Sufalam, Malayaj Kalam, Shamalam, Vande Mataram. Kalam Sufalam, Malayaj Kalam, Shamalam, Vande Mataram. ना ये ज़मीन आसमानों में दो जहानों में जज्बे इरादे और ये जुनून बनते हैं दिल के कारखानों में पहुंच गए हम पर से आगे धरती से फिर भी बंधे हैं धागे रहते वतन की मिट्टी से जुड़ के जय हिंद जो नस नस में है हर बाजी फिर बस में है जिद ठानेंगे हिंदुस्तान Sujalam Sufalam, Malayaj Kalam, Shamalam, Vande Mataram. Sujalam Sufalam, Malayaj Kalam, Shamalam, Vande Mataram.
That was a memory recalling video of KIYE. Now, to give us a deeper understanding of KIYE and its mission, I now invite our passionate student leader, Ms. Siddhika, to share a few words about her experience in KIYE. Ms. Siddhika, the mic is yours.
Thank you, Deepshika, and good evening to all. Respected Dr.A.S.Kiran sir, we all are eagerly waiting to hear from you and are truly honored by your presence today. I am Siddhika Khatun from VMTW and I am delighted to share my journey as a student coordinator at Kalam's Institute of Youth Excellence, KIYE, a visionary organization which has been inspiring and empowering youth since 2013. And being a part of KIYE has truly been transformative for me because it has strengthened my technical knowledge, leadership qualities, communication, and decision-making skills. The major highlight of my journey was serving as a coordinator in the hospitality department during Kalam Space Convention 2025 at GMR Arena. This role gave me the privilege to directly interact with the eminent experts and chief guests, where I learned about many upcoming things. I also had the opportunity to attend the Aryabhata Space Utsav lecture series, where the space experts and tutors shared their deep insights about science, space, and innovation. My heartfelt gratitude to the chief mentor, Dr. G. Satish Reddy sir and Naresh Indian sir, for their constant guidance and support. And for anyone seeking knowledge, exposure, and growth, I strongly encourage you all to join KIYE, a platform where passion truly meets the purpose. Thank you, KIYE, for helping me learn, lead, and grow. Jai Hind.
Thank you so much, Ms. Siddhika, for that inspiring journey. Now, let us take a look onto the video of Ms. Drakshi sharing her experience in KIYE.
Hey everyone, I am excited to share my journey with KIYE Kalam Institute of Youth Excellence. From being an audience member to becoming a student coordinator, KIYE has helped me learn, build confidence and develop teamwork skills. I have even met inspiring personalities like ISRO chairman Somnath sir. What I love about KIYE is its focus on personal growth and nation building. We are working to strengthen India's defense and make a positive impact. If you are looking for a platform to unlock your potential and become a leader, join KIYE, hurry up and be a part of something amazing.
That was a motivating video by Ms. Drakshi. Now comes the highlight of today's lecture. We are greatly honored to introduce Dr.A.S.Kiran Kumar Garu, who stands as a pioneering figure in India's space program. With a career marked by technical innovation and leadership at ISRO, his journey from the early education to heading the organization showcases the dedication to space science and its societal benefits. Kiran Kumar Garu, born on June 13, 1961, in Karnataka. Dr. Kiran Kumar Garu pursued his schooling in Bangalore, developing an early interest in electronics and optics. He completed his pre-university education at National College, Jayanagar, excelling in science subjects that laid the foundation for his future in space technology. He earned a bachelor's degree in electronics and communication engineering from the University of Bangalore in 1982. Advancing further, he obtained a master's in electronics from the Indian Institute of Science, IISc, Bangalore, followed by a PhD in the electronic communication engineering from the IISc in 2004, specializing in electro-optical instrumentation, later joining ISRO in 1982 as a young engineer at the Space Application Center, SAC, in Ahmedabad. He contributed to electro-optical sensors for early satellites like Bhaskara and IRS-1A. By the 1990s, he led payload development for IRS-1C 1D cameras, advancing high-resolution Earth imaging capabilities. Dr. Kiran Kumar Garu played a vital role in Chandrayaan-1 2008, designing a terrain mapping camera that provided India's first high-resolution lunar images. He led the Mars orbiter mission, Mangalyaan 2014, ensuring compact optical systems for Mars navigation and relay, making India the first nation to succeed on its maiden Mars attempt. His work extended to navigation systems like IR, NSS, navigation IC, and communication satellites. Leadership roles and awards appointed are SAC Director in 2007, Secretary, Department of Space, and DOS Chairman in 2015. He served as ISRO Chairman until 2018, overseeing record satellite launches including PSLV machines and GSLV Mk3 development. Awards include Padma Shri 2014, Padma Bhushan 2017, and IEEE Region 10 Simon Ramo Medal. Recognizing his sensor innovations and space leadership, later milestones post ISRO, he chaired the Indian Institute of Space Science and Technology, IIST, and contributed to global forums on space applications. His focus remains on leveraging space tech for agriculture, disaster management, education. We are truly privileged to have such an inspiring personality with us today. Sir, the virtual stage is all yours.
Thank you very much, and thanks for this opportunity to be part of this Kalam Institute of Youth Excellence, which is trying to bring in the developments and also the ability of science and technology to deal with societal problems. So what I would like to do today is just take you through a journey of how India started its space program, where it is heading today, and in the process, give you some of the key insights into what technology is meant to be and how technology has been handled in the country. See, probably for this audience, it would not be difficult to see that humanity, in a way, got a new technological capability of going beyond planet Earth when Russia put its first Sputnik into orbit. And at that time, it is the intense competition between the two superpowers which was actually trying to determine who is ahead of the other. So obviously Russians put the first Sputnik into orbit, they put the first man into space, first woman into space, first dog into space, and then they were going ahead. And Americans felt they are left behind. So they decided they will work and then put man on moon. So by 69, they did that. But then what has this got to do with India and then how India developed? If you look at this ability of the humans to go into space is a technological capability which you can talk of as a disruptive technology in the society. You are familiar in today's world how technologies bring in new capabilities which bring in a huge change in the way we live in this world. So obviously 1957, if you look at, it was just 10 years into independence for India. We had got independence after many centuries of external rule, and in 1947, India got its independence. So you can really visualize at 1957, it is just 10 years into independence, and India as a country was struggling to provide food, shelter, education to its citizens. If at that time somebody were to tell you can go to space and make a difference to the country, what would have been the response? You can guess yourself. But then there was a great visionary scientist like Dr. Vikram Sarabhai who realized that the ability of putting an object beyond Earth can be used for the rapid development in the country, a developing country like India. So what was done? He convinced his friends across America, Russia, France, and Germany and started doing space activities in India way back in 1963 when the first sounding rocket was launched from Tumba. But for doing that also, he had to actually get in the beach in Tumba, he had to convince the fishermen and telling them, you vacate this place for us to conduct this experiment. One day the country will benefit. For that, he had to take the help of the priest of the church there. Many of you would have seen in the photograph a dilapidated church. Priest of the church service was used to convince the fishermen that they should allow us to conduct these experiments. And then that's how it started in 1963. November 23rd, India launched its first sounding rocket, which was assembled as a sort of a do-it-yourself kit brought from the Western countries and assembled in that church and launched. But then what has this got to do? See, from 1999 onwards, what India did was, by an orbiting satellite, it looks at the color of the ocean from space. And by looking at the color of the ocean in 8 different wavelengths, you can find out where is the chlorophyll. And from chlorophyll, you can look at the food chain of the fish. That means algae which consumes chlorophyll and some other life form which consumes algae. So like that, based on that, you can tell where in the ocean, if you go, the fisherman is assured of catching the fish. Now you can see what happens. India has a coastline which is almost 11,500 kilometers. Lakhs of fishermen depend for their livelihood on catching fish. So now this particular activity of telling the fishermen where in the ocean you are assured of fish catch, this information started getting disseminated in Hyderabad. There is a center called Indian National Center for Ocean Information System. Through that, this message of where the fisherman has to go for catching the fish was being disseminated. At that time, through pagers and then telex and that kind of thing. But then later, we also added a new capability with our own navigation satellite. You know what a navigation satellite does? A navigation satellite helps you locate yourself. For example, in the mobiles, the GPS shows you where you are. Now, how does it happen? See, suppose somebody were to ask you, I want to come to your house. How do I come? You will say, okay, about 100 meters from my house, there is a clock tower. And in northern direction, there is maybe a temple or a school. So you will find out some 2-3 references. And from there you tell, I am at such and such a distance from this place. That means you can locate an object by referring to a reference point, and then if you know the distance from the reference point, you can do triangulation and find out. So what space does is, by putting satellites in orbit, signal is sent from the satellite. A device which you hold in your hand is able to locate where it is by finding out how much time it took for the signal starting from the satellite to reach you. By taking 4 reference satellites, you will be able to pinpoint your location. So our navigation satellite is now a gadget, in a battery operated gadget is fitted in the boat of the fisherman. Now this gadget communicates with Navig satellites and locates itself where it is in the ocean. Next thing is, the prospective fishing zone is broadcast as latitude, longitude information. Now a mobile in the hands of the fisherman, you can visualize when the mobile is few hundred meters away from a terrestrial tower, no signal is available. So if the fisherman is into the ocean few kilometers, no terrestrial tower can reach him. But satellites can reach, and then the mobile communicates with the gadget we fitted in the boat of the fisherman, and an app in the mobile points to the fisherman in a video compass mode where he has to go for catching the fish. Not only that, if in the coming days, if the weather conditions are going to be unbearable, sea state is going to be very rough, or wind speeds are going to be huge, then he gets an alert in his mother tongue. So he can come back to the shore and save himself. And also many times you would have read in the papers, our neighboring countries capture the fishermen because they wade into their international boundaries. So now this gadget, mobile, alerts him in his mother tongue that you are approaching international space, international water boundaries. So be careful. So now you can see here what is happening. A person who does not know reading or writing is capable of using the most advanced technology of a rocket, putting a satellite into orbit, and that satellite identifying where in the ocean, if he goes, he can catch the fish, and getting weather alerts, etc. So India started making use of space technology for helping people who are not even literate. This is one example. Now another example is, in 1975, India conducted the world's largest socio-technological experiment. Probably if you ask your parents and grandparents, they'll tell you in 1975, in India, only 4 metros had the privilege of seeing television programs. Bombay, Madras, Calcutta, Delhi. No other place you could even see broadcasting. So, but what Dr. Sarabhai did, he was aware that if you are able to put a satellite in 36,000 kilometers, which is called as geostationary orbit. What is a geostationary orbit? It is at 36,000 kilometers from Earth. If you put this satellite, it takes exactly 24 hours to go around Earth. And you know, Earth rotates about its own axis once in 24 hours. So what happens to the relative velocity between the satellite and a person standing at the equator? Practically zero velocity. That means the satellite appears like a tower at that height. See, normally what you do when you want to see far away distances, you climb higher and higher. You go to a mountain top, you can see large area. You go to tree top, tower top or mountain, then you can cover large area. Same way, this particular satellite, when it is at 36,000 kilometers, can actually look at 1/3 of the globe simultaneously. That means the entire India, you can broadcast a signal and receive there. So what Dr. Sarabhai did was, he convinced Americans that they should allow us to use one of their advanced technology satellite, which was called ATSF, Advanced Technology Satellite 6. And it was moved over Indian longitude for 1 year. And using that satellite, signal was broadcast. And in 2,400 remote villages of our country, ISRO had set up what is called direct to community television sets. Probably today you are all very familiar, a small quarter-meter antenna on your rooftop and a set-top box allows you to see the video program. You imagine in 1975, India, ISRO demonstrated to the country that using space technology, it is possible to build a mechanism where villagers can be showcased about information. It could be the agricultural practices, health practices, various information which you can provide to the remote villages. And this experiment was conducted in 1975 for 1 year. And with that experiment, the government got convinced that if in India, if we have to quickly bring in communication revolution, it is possible only if you use space technology. What was the alternate that was available at that time? Many of you would have seen microwave towers. Every tower, 1 kilometer apart, if you put a tower, then you can do communication. And you know, India is 3.25 million square kilometers. So now you can imagine how many towers you would need if you have to cover the entire country for linking, for signal and broadcasting. So again, and also how much time it would have taken, how much of equipment would have been needed. But compared to that, by using a single satellite broadcasting, instead of a quarter-meter antenna, at that time, we had used 10-foot diameter antenna on the ground. And instead of a small set-top box, it was half a rack height of front-end electronics. With that and the black and white television set from ECIL, ISRO demonstrated that we can rapidly bring in information to the society by space technology. So that's how government got convinced. In fact, at that time, it was the world's largest socio-technological experiment conducted by anybody in the world to demonstrate space technology can benefit developing countries by rapidly bringing in communication and broadcasting capability. So with that demonstration, India started its INSAT program, which provided from 80s a capability of both the broadcasting as well as telephone connectivity, etc., etc. Another very important thing that happened is you can also visualize when super cyclones come, they hit the coast, and in the earlier decades, tens of thousands of people used to lose their lives because they would not be knowing when the cyclone will hit the location. But today, by looking at the cloud motion and various parameters which are measurable from satellites, it is possible to predict exactly where and when a cyclone hits the coastal region. So with this, today what happens? Disaster relief agency is able to evacuate the people from that region and save their lives. So that's how you have seen in the recent decades, no super cyclone results in loss of life more than a single digit. And that too because many times people do not heed to the warning that is given. But otherwise, India is effectively managing super cyclones, not resulting in loss of life. And similarly, using satellites, you can collect information about what is the crop yield this year, how much of cotton is grown, whether it's sugar cane, jute, rice, wheat, you name it, more than about 21 different types of crops. It is possible to tell before harvesting what is the yield this year so that the government can plan both for importing or exporting or for various activities. Similarly, using the data from satellites, you can also identify where you should drill a bore well to get water. So a whole lot of information which is collected from satellites being used. And like I was saying, in 1947, when India got its independence, it was at a very low position in the economy. Gradually, it started building up. And then with the capability from space technology, bringing in communication, broadcasting, weather monitoring, resource monitoring, a whole lot of activities, these inputs were being provided for governance. And then government started using it more and more, and they improved the living conditions in the country. And also, as the technological capability became more and more, see, obviously you can visualize that in India, or India is the only country which started space program for non-military activities. Otherwise, every other country in the world started space activity for military application, because you can easily visualize. You can do a lot of things from space which can be advantageous for dominating over others. And otherwise also, you are very familiar that it is human nature to take advantage of the capabilities that you have to dominate over others. But then India started using space technology for bringing societal benefits as the primary objective, and that's how the program started. And then step by step, like I said, in the 60s, sounding rockets, starting with almost like do-it-yourself kit, getting it from a Western entity, assembling it. But then we started building our own capability. Today, we have more than 4 versions of the launch vehicle, which can take satellites to different orbits, to low Earth orbit, geostationary orbit, even for Moon, Mars, Lagrange point, like that. So all of this is a gradual development which has been done to meet the requirement of the country. And then as you started building your technological capability, this area being dual use, information is not easily available to you. So you have to do a lot of things by your own effort. And like probably many of you are aware, Kalam was the project director for the first launch vehicle, SLV launch vehicle that was being built. And in any case, you visualize that when you are doing things, if you want to ensure that you succeed in what you are doing, you have certain knowledge and certain skills. If you want to make sure that you will succeed, you have to remain within this knowledge base and skill base. If you try to do something beyond this, then what is assured? Success or failure, because you want to achieve something which you have not done so far. That means it is not within your current knowledge set or skill set. So you are trying to push yourself beyond your current boundaries. So when you are trying to do such a thing, are you assured of success or are you assured of failure? Think about it. So normally what happens? You are now going beyond your current limits. So what is assured is actually failure, not success. That's how, for example, Kalam has been saying, what is fail? Fail is first attempt in learning. That means when you try to build something beyond your current skill and capability, failure will occur, but then you should not be deterred by that. Treat it as a first attempt in learning, rectify the problems you face, and then go ahead. That's how, for example, the very first launch, when it happened, Kalam was the project director and Satish Dhawan, who was the chairman of that at that particular time, he told, the press conference was there immediately after the failure. Then Satish Dhawan told Kalam, you stay here, I will face the press. So he went to the conference, he spoke to them and then explained the difficulties and all that. And then he dealt with the problem. Next time, when the SLV succeeded, he told Kalam, you go and face the press conference. So now you can see that how you deal with failure is an important aspect. And then failure is probably assured if you are trying to do something beyond your current skill and capability. And if you want to achieve something, then naturally you have to push yourself beyond your current limits. Then only you can do something bigger or greater. So anyway, it started from SLV, then went to PSLV, JSLV, Mark III, then like that. We also now started looking at how to improve the skill and capability of the scientists and the engineers and technicians. When you give them more challenging tasks, they will be actually doing overtime on their design, thinking, analysis. They'll come up with better and better solution. So going up to 36,000 kilometer was what was required for geostationary satellites. But then moon is at a distance of 384,000 kilometer, roughly 10 times farther than moon. So India took up a program where we will go to moon and orbit the moon. And then when this was done in 2008, man had already landed on moon. A large number of probes had touched the surface of the moon. But still, 2008, when India launched this Chandrayaan-1, what was the credit it got? The credit it got was it discovered for the first time the presence of water molecules, demonstrated that water molecules are present. The process of water molecule formation was actually determined using the instrument that went on this satellite. So what does this show you? It is never too late in science and technology to do something others have not done. Man had already landed on moon, but still to show that water molecules are present, presence of water molecule, how it happens, it was requiring India's Chandrayaan-1 mission. That's how, when again, earlier till that point of time, people thought moon is bone dry. But then presence of possibility of water on moon triggered a whole lot of activities. Today you see there is a lot of interest in going to moon, landing there, manned missions, etc. are all going on. So again, showcasing to you that it is never too late in science and technology to showcase to others that you can do something which others have not done. Similarly, when you look at Mars mission, what happened in Mars mission? India demonstrated that for the very first time in its maiden attempt, it was able to put an object which went around Mars. And what was the difficulty of this mission? This satellite on launch from Sriharikota on 5th of November 2013, the task cut out was travel a distance of 600 million kilometers, 60 crore kilometers over 10 months. And at the end of that period, at a specific date, time, to the second, satellite had to be inside. You imagine a cube of 50 kilometers, 50 kilometers in space. So this satellite, after traveling for 10 months and 600 million kilometers on a 24th of September 2014 morning 7:30 a.m. to that second. In that second, it had to be inside that. If it were not there, it would not have been possible for us to make the satellite go around the Mars. But all that was achieved, showcasing that it is possible to do things in your very first attempt also. And then here, if you see the kind of forces that could have affected, even sunlight falling on an object, produces what is called as a radiation pressure. So radiation pressure is like you take a piece of paper, blow some air from your mouth. It is such a trivial force. But even such force over a period of 10 months can take this satellite hundreds of thousands of kilometers away from your target. That means you have to worry about how to make sure satellite is in the right direction, it is traveling, and then communicating with that. And also it takes almost 13 minutes for the signal, radio signal, traveling at the speed of light to reach that point. It takes almost 13 minutes, 12 to 13 minutes. That means you give a command from your computer station, the signal takes 12 to 13 minutes to reach there, and after another 13 minutes, it will tell whether what you have sent has worked or not. That means almost half an hour. Many of you, when you start your computer or laptop, will start feeling fidgety. My system is very slow. It takes few hundreds of milliseconds to boot up. I need a faster system. So you can imagine the people sitting on the console, how they would be feeling. What they have done, they have done. They are now waiting for the signal to come. Wait for half an hour, etc. Anyway, basically the point is, when you do things which is more and more difficult, it challenges you and it makes you learn newer things and build more and more capability. Similarly, when you look at Aditya L1 program, it is a satellite which was built to look at what is happening beyond the sun's photosphere. So in this fashion, India started developing its own indigenous capability of building a space program for helping its growth in the areas of communication, broadcasting, weather monitoring, remote sensing. And also, as you keep growing, while India started its program purely for non-military application, today you have reached from a very low position in economy to fourth largest economy, and you're aspiring to reach by 2047 the almost at the top. So if that has to happen, you need to make sure you are competent. So unless you build competence, you cannot be one among the equals. So many of you are very familiar how in atomic energy area, since India did not do certain things at certain time, it had to bear the brunt of non-proliferation treaty, etc., etc. So today, even the government is clear, it doesn't want India to face similar situation. So it is saying it is not only the government that should work in space activity, but also space economy is $1 trillion economy. So more and more people should participate, and India should also get a decent pie in this economy. Because if you want to improve your economy, you need to be active in all the main areas. So India also started telling that not only government, but also private entities should operate, all commercial activities they can do. Then there could be separate defense activities, a whole lot of things. That means making space activity happen in non-government area also is an important thing, because India can build this capability. So already large number of companies are building launch vehicles. You have already heard a company has done its own 3D printed engine, and maybe within this year, they'll be actually doing the testing of their rocket to actually launch satellites into orbit. So a whole lot of things are happening. So what India has done, if you look at in this sense, started from a beginning where it became the first country to make use of space technology for non-military application. So it has become one among the equals in space technology area, and wants to build this capability to remain relevant in the coming years, because unless you are competent and you demonstrate your competence, people will not recognize you. I'll give you one example of this. See, last year you saw, I said 1975, India borrowed the American satellite for 1 year and then used that for demonstrating sight. On last year, July, we launched a satellite. Some of you would have read. It's called NASA ISRO Synthetic Aperture Radar Mission, NISR. Now, this is one of the most advanced technology satellite in the world today. It generates more data than all the remote sensing satellites put together. It can monitor the health of the Earth in water bodies, solid Earth, atmosphere, and all this data is also made available to global community. This advanced radar is built by an American entity in NASA JPL, and it has a 12-meter diameter antenna, 36 feet diameter. When it goes to space, it opens up the antenna to a very large size. Such a complicated payload was actually housed in our satellite, and we launched it because now NASA and its USA trusted India to work as a collaborator. Earlier, they had allowed us to use their satellite for demonstrating some capability. But this time, they worked with us as a compatriot and a common mission. And this recognition happened because of what? Why did they trust India to launch this satellite? Because now they are confident of the capability that has been built. And this happened after Chandrayaan 1 and many satellites, radar satellites we had built. So they were ready to work with us together as in a common mission. So the point I'm trying to make is people recognize you for your demonstrated capability. So if you want to show your competence, you have to demonstrate. And when that happens, then people recognize you. In the same way, for example, you also have seen ASAT capability, like that, many other things. But then, not getting into all other details, basically my idea of bringing you the narrative is India started its activity at a point of time when the space technology was being looked at for development for military applications. And at that time, India made use of it, gradually built its capability. Today, you have seen how these capabilities have helped the country in dealing with many situations that we encounter, what happened last year, what happened previous years, etc. So in all this, basically the idea is that you need to make sure that you develop your competence, you develop your skills. Only when you do that and demonstrate that, people will recognize you. So that is what actually, if you look at what Kalam has been saying also, is that you need to build capability and competence. And when you are doing that, what is assured is more failure than success, but you should not be deterred by failure. You should find out, say, like I said, Chandrayaan 3, when we landed, we had failure in Chandrayaan 2, but then we found out what all went wrong and then rectified them. So basically, the whole process of building competence requires you to push yourself beyond your current boundaries, current knowledge, current skills. Then only you can do something different from others. And then that's how you can grow. So like this, if actually I can keep going on and on indefinitely. So I'll stop here with the primary point which I want to drive home to you is the importance is using technology for solving the problems you face should be the objective. Technology development itself is not a key thing. How you can use a technology for doing what you want. That's how India has shown to the world also that using space technology, you can solve many problems of a developing country and then grow yourself. And then today, constantly this development is happening. And then all of you who are listening to this and who have the task of seeing by 2047, where do you want India to reach? Obviously, you're all very clear about that. You don't want to see what happened in the past millennia. India was at the leading edge, but then various things ensured that you went down, but now you have an opportunity to regain and then reach a place which is the due place for you. Because this land has always shown that technology in itself is not the end. Human existence, human survival, and survival of life on planet Earth, if it has to happen, humans should also realize that the world is not just for humans. All other life forms are also important. Nature is also important. Only when you pay respect to nature and treat all other life forms as an essential component, then that is the Vasudhaiva Kutumbakam and the various this land has shown to the world. If you appreciate, you will realize that any technology development that you do is meant for improving the conditions of life, helping you live a better life. Living a better life using technology should be the aim and not technology for technology's sake. So let me stop here. And if you have any questions, I'll be more than happy to take and answer.
Thank you, sir. Thank you so much for that inspiring session. Your words add value to the young minds. So now we open the floor for a short Q&A session. If you have any questions, please drop them in the YouTube live chat and we'll address a few questions right now. And I request our guest, Dr.A.S.Kiran Kumar Garu, to have few questions from our audience. Sir, my first question is what guidance would you give to the students who is pursuing electronics and communication engineering who want to build a career in launch vehicle technology?
If you look at space technology today, what is India trying to do? Now, India has already decided we will put humans around Earth. In next couple of years, that will happen. By 2035, you will have a space station. By 2040, you want to land Indians on moon and bring them back safely. So if you look at this task, it's a huge task. You have to carry life beyond Earth. You have to make sure that you provide all the environment conducive for their survival, and then take them to a place like moon and then bring them back. So there's a whole lot of activities from communication, control system, understanding life and food. The number of items and the fields are very large. So you don't have to be restricted in any one field. You can be doing whatever you are doing, but still, if you are capable of bringing a solution to the problems of this particular activity, of taking people from Earth to moon and bring them back. And again, even after going to moon, also build space habitation there. Like that, whole lot of things are possible. There is a huge amount of opportunity here for the young minds to identify problems and tackle those problems even as they are equipping themselves with the skill set. You are talking about electronics itself, communication. Obviously, how to do communication in a manner which consumes less power, and then you can do large amount of data transfer. That means bandwidth requirement. Then you also want to make sure that it is safe, it is encrypted, and then technologies, using technologies like quantum technologies, using them. So opportunities are many. You have to visualize. Here I also want to bring in one more thing. What humans are doing so far is taking inspiration from nature. See, earlier humans, you could walk few kilometers an hour, but then you saw a lot of animals moving around much faster than you. So what did you do? You domesticated them, started riding them, so that you could travel farther with less effort. You saw birds flying. So today you have built enough gadgets to take you in air. So now you are building vehicles to take you to other planets. So that means nature has so much of inspiration. And then those who are capable of observing nature and then bringing that into reality achieve success. I'll also give you one other simple example. As a human system, our ability to make observation of around us is based on the 5 sensors we carry, correct? We can see through our eyes, but eye has a design limit. It can operate only between 400 to 700 nanometers. But now you visualize what all humans have. Okay. Yeah, I got disconnected for a short time. So basically what I was trying to tell is the sensors that you have has a bandwidth and a limit. So what humans have been trying to do is take Yeah. Hello. Okay, I'll just complete. So what it's trying to do is, by looking at nature's inspiration, build things, and then if you take this argument, you will see everything that the humans have created in this world, no matter what domain, what field you take, is all inspired by what is happening in nature and bringing that into reality. So if you pay attention to this, your ability to explore the world can help you in doing things. So nature has enough. I'll just give one example and close. See, today, suppose we were asking you, can you build a car or a robot which can reproduce itself by picking up material from surrounding it? So now if you think about it, you see around you in nature, all plant-based life forms reproduce themselves from seeds. All egg-based life forms reproduce themselves from eggs, mammals, and you take any life form. Every life form picks up the same 5 raw materials in this universe, what you call as panchabhutas, air, water, soil, etc. Using these 5 elements, it is reproducing itself. So can humans start producing things which can reproduce itself by picking up material from surrounding it? So now you see what all challenges it throws open. So if you start thinking about that, you will see enough problems to solve. So thank you very much, because I have a flight to catch. So if you want just one more question and then I can close.
Okay, sir. Thank you, sir. I request Chaya Mishra from Methodist College to present a question.
Good evening, sir. It's me, Chaya Mishra from Methodist College, sir. Sir, my question is, as we know, ISRO is making very rapid advancement in Vikram 32, Chandrayaan 4-5, and the Gaganyaan human space flight. Still, as an engineer, it is understandable that technical challenges are the part of complex mission. So, in this context, how has the recent PSLV C-62 anomaly impacted ISRO's mission and vision? And how can students and the general public positively contribute to the space program while avoiding negative perceptions among the public, sir?
No, this is where what I was trying to tell you is, see, when you are trying to do things which is extending beyond your current limits, etc., but then in any system, even when you have done, that's why it's called rocket technology, that there are so many complexities and so many intricate details. If even something goes wrong in any one of them, it could result in failures. That's where space technology, failure, even if you have done 100 times successfully a launch, 101st launch, you could encounter some difficulties. It could be a whole lot of things. So the effort, but the point what you have to appreciate is every time such a failure has occurred, what ISRO has done and how it has demonstrated that it is capable of building the correct solution. So like I said, first launch vehicle, and then even Chandrayaan 2 when it failed, then Chandrayaan 3, you came up with successful thing. So when you start addressing the problems you have faced, identify them, tackle them, you will succeed. So these are all probably like failure being the first attempt in learning you are talking about. Others also say success results in you becoming the first to fail. That means if you have had a series of success, then the next one, when you encounter a failure, it's also a possibility. But anyway, that's the difficulty of a space program. We need not get too much concerned that there are problems here. It will be identify what went wrong and then corrections will be done and you will move ahead.
Thank you, sir. Thank you so much.
So thank you very much. So give me permission to leave because I'm heading straight to airport now to go to another place from here. Thank you very much. Wish you all the very best and then wish your KIYE a great success in what you are doing. A fantastic job you are doing. Keep it up. Thank you.
Thank you, sir. Thank you so much. Your leadership add value to the ISRO to stand on its own feet. Thank you so much. As we come to the close of this remarkable session, I invite Miss Siri to present a vote of thanks.
Thank you, Deepshika. Good evening, everyone. On behalf of the KIYE Foundation, I'm Siri, BTech graduated Aeronautical Engineering, representing entire organizing team of Aryabhata Space Lecture Series 10. We extended our heartfelt gratitude to our esteemed speaker, Dr.A.S.Kiran Kumar Garu, former chairman of ISRO, for delivering such an inspiring session on space technologies.
Sir, your words have truly ignited a scientific curiosity among our students, educators in the field of space technologies. We also express our sincere thanks to Dr. G. Satish Reddy Garu, former chairman of DRDO, Dr. V. Narayanan, chairman of ISRO, and Dr. Prakash Chauhan, director of NRSC ISRO. For their constant guidance and mentorship is continues to inspire the KY Foundation and Aryabhata Space Lecture Series. This session is a powerful reminder the space is the next destination and we must be explored together. Before I conclude, I warmly invite everyone to stay connected with us for upcoming invitations. Join our WhatsApp channel, subscribe our YouTube channel, follow us on Instagram, visit our official website for future update. Please mark your calendar. Our next Aryabhata Space Future Lecture Series will be held on 21 February 2026. We are looking forward. Your active participation will be once again. Let us carry forward the legacy of Aryabhatta and Dr. APJ Abdul Kalam by nurturing a scientific temper and delivering such a session on career building. Thank you once again. Jai Hind. Thank you, Siri, for those wonderful words of gratitude. I would like to end this session by extending heartfelt thanks to Dr. G. Satish Reddy sir for mentoring KIYE, followed by sincere gratitude to ISRO Chairman Sri V. Narayanan sir, and to Director NRSC Dr. Prakash Chauhan sir for their constant support and guidance. We are truly honored by their encouragement towards the Aryabhatta Swarna Jayanti celebrations organized by KIYE to commemorate 50 years of India's first satellite Aryabhatta and to inspire young minds in the field of space research. And as we conclude today's event, I would like to share a exciting news. National Science Day 2026 is just around the corner, and we are thrilled to announce Vigyan Vaibhav 2026 on 28 February 2026 at Gachibowli Indoor Stadium, Hyderabad. Get ready for an incredible space convention with school students and a fantastic project expo showcasing innovative ideas. Mark your calendars and join us for the spectacular celebrations of science. See you there. And I also thank everyone who joined us. Thank you for being part of Lecture 10 of Aryabhatta Space Utsav. Let's continue this exciting journey together as we explore new things in science and space. And I request everyone to subscribe our YouTube channel, KY Foundation, for future sessions and also join our official WhatsApp channel for the updates and announcements. Links are provided in the description. Let's stay connected, stay curious, and keep reaching for the stars because truly, we strongly believe that space is the next destination. Let's explore it. Have a wonderful evening, everyone. Thank you. Jai Hind.